I want to start with a quick show of hands. Are we DC locals? DC locals in here? Okay. Mix. How many of you, maybe since you got to DC, have wondered what the helicopter is circling? Do we have any of those? Any of those? Okay. Well, my name is Andrew Logan, and in 2020, I started a Twitter account called Helicopters of DC in an attempt to answer Washingtonians' burning helicopter questions. If you're not from DC, it sounds like there's a good number of you. All you have to know is that DC is frequently flown over by a number of operators, police chasing carjackers, medical helicopters transferring patients, the Marine Presidential Squadron, DHS, Coast Guard, Army, National Guard, and Air Force, all doing important missions, also doing a ton of training. And this has generated a lot of interest among area residents. It has also, created some strife, whether it is having your workday interrupted by the sound of freedom or actual civil rights violations, like this National Guard helicopter performing rotor wash over protesters at the George Floyd protests in 2020. You might have also seen this technique go viral recently as a park police helicopter used it on ice skaters on the National Mall. So I know we're all problem solvers in this room. I want to walk you through the various problems and solutions that I found when approaching this project. The first problem, there's a general lack of knowledge about helicopter operators in the DC area. And of course, as OSINT people, we can start with the obvious things like looking at military bases on Google satellite imagery and counting helicopters. But somebody kind of did the work for me because Government Accountability Office issued this report on aircraft noise that included, this was in January 2021, that included an appendix with each operator, how many of what type of helicopter they fly and from where. So they did all my background recon for me. Other great GAO reports, military reliability and threats to DoD from technology that track military aircraft. And that kind of leads us to where our project started as a humble ADSB bot. So if those combination of letters doesn't mean anything to you, this is just an account that periodically announces publicly available flight data on Twitter. Now, I'm going to do some background. Hopefully this is helpful to some of you. ADSB, not the only transponder protocol out there, but it is the most current and it's the most data rich. And it stands for Automatic Dependent Surveillance Broadcast. So let's break that down. Automatic means it doesn't require the pilot's intervention. Dependent on a number of other data sources like GPS for geometry or the radar altimeter for altitude. Surveillance because it reports that location over broadcast on 978 or 1090 megahertz unencrypted for reception by ground stations, but also for reception by individuals and enthusiasts like us. And flight aggregators, many of them at least, rely on volunteers like us to receive these waves from our local area via a Raspberry Pi, an RTL SDR, and an antenna, and upload them to the internet where they can be displayed on a world map. And speaking of the world map, this is where we stand with ADSB mandates as of 2024. Many of these started going into effect in 2020. The countries in blue, like the US and some of Europe, require ADSB be used in busier airspaces. The countries in orange, like Canada and some of Asia, require that it be used at higher flight levels. So you may have very good coverage of a jet across the entire country, but a low-flying helicopter over an urban area, you may not have any coverage in these countries. And the sole country in green here, Colombia, requires ADSB be used at all flight levels and in all airspaces. And I asked a Colombian friend what he thought. He thought maybe the unique terrain and weather patterns of Colombia could cause issues, or maybe they just definitively want to know who the narcos are. So at this point, the policy badger is going to interrupt me to tell me I have to tell you about some legalese. This is the FAA's LADD list. which you've probably heard come into the news with regards to Elon Musk and Taylor Swift recently. But this is the stipulation that if you receive flight data from the FAA's feed, which is called SWIM, System-Wide Information Management System, then you are required to remove LAD list data from that account. But if you do not receive your information from the FAA, you are not bound by this contract. And let me tell you about some of the numbers that you'll see on flight aggregators. This, of course, is your flight number. You'll see this on your ticket when you fly commercial, and the pilot keys this in the cockpit, so it is not a unique identifier at all. Slightly more so is the registration, which is what ties the aircraft to the FAA's database. And this is printed on the tail of the airplane, so it's somewhat permanent, but we do see craft get repainted with new registrations. What we really want to look at is the ICAO, or hex number. This is a 6-digit hexadecimal code assigned by the International Civil Aviation Organization. This was established in 1944. And this is, you could think of as the primary key to the aircraft database. That is unless you are a user of the PIA list that the FAA allows individuals with certain needs to subscribe to. And this lets you disassociate from your assigned ICAO number for one from a predefined list. Of course, hackers have figured out what this predefined list is because it doesn't tie back to the FAA registration. So some of the aggregators that you may consider using, I used to unequivocally recommend ADSB Exchange as the community flight tracking option. However, they were purchased by a private equity company last year, so still very good data, pretty low cost. But the great news is for OSINT analysts, we can now use a variety of free options from the new community resources, such as the air traffic, which is run by Elon Jet's Jack Sweeney, ADSB.FI, which is run by former ADSB Exchange employees or developers, and a couple other options, airplanes.live, ADSB.LOL, and ADSB.1, all have very good data for our use case. And commercial aggregators, in this case, FlightAware and FlightRadar24, are subscribers to that SWIM data feed I mentioned. So they have very rich data, not anything that's on the LAD list, but you do have to pay a price to use their information. And the sole research one here is OpenSky Network, and they are based in Europe. They have a free API, but I believe they may be bound by other EU privacy laws. If you're interested in becoming a feeder, I highly recommend it. ADSB.IM is an image for single-board computers like the Raspberry Pi that can get you started feeding all of these different services with just a couple checkboxes so that you can contribute to this data set, and we need you. These are some of the API endpoints that are available to you for free from the community services at the top here. You can look up aircraft in a certain radius, aircraft by hex code, aircraft by call sign, by registration, by types of aircraft, by squawk codes. Squawk codes are used in emergencies, but also just to identify with the tower. A list of military tagged aircraft, a list of PIA aircraft, as we mentioned, and a list of LAD list aircraft. And you can try this right now, and if you have a laptop in front of you, you can type in any of these services /v2/LADD, and you will get a JSON list of LAD list aircraft that are currently in flight. So that is the one thing to know about this, is it is live data. There's no API for historical data that I'm aware of, for free at least. And if you have a few friends like I do, you can start your own aggregator. We use MongoDB to store these data points. It's a very low cost and flexible solution and offers you that historical access via an API call or a native Python driver. But I'm not going to go into more detail on that. So we faced our next problem here, of course, now that I've told you all about ADSB, it's not actually that useful in the DC area. And the policy badger will return to tell us why it is the Code of Federal Regulations that offers an exemption for government and military aircraft that are performing missions of national defense, homeland security, intelligence, and law enforcement. And we find that this exemption is very broadly applied. And to demonstrate that, I want to show you an investigation we're working on that has, for example, we're going to use this aircraft from the Air Force 1st Helicopter Squadron. If you are in DC, this is one aircraft that is probably the most predominant over the area. They operate 21 of these Vietnam-era UH-1N Hueys, so they have to fly them a lot. And they are responsible for transporting generals, diplomats across the region, and a lot of training. And one day last May, they were transporting commanders. Not military commanders, but Washington football players. Now, I challenge any of you in this room, please give me legitimate answers after this, why you would need a national security ADSB exemption to take football players to take photos of their stadium. So let's see if they used it. We can start by downloading this photography. Joint Base Andrews very generously lets us get super high resolution TIFFs. But we can download more photography from Devids Hub. Now that sounds like a sketchy website, but it's actually the Defense Visual Information Distribution System. And you can even set up news alerts when different military things are happening or keywords that you want to hit, and it will tell you when new photos and videos are added, and many of them are public domain under a lot of circumstances, which is great. So we download this, and we plug it into Exif Tools. Now, Exif Tools, if you have sensitive data, you could run it on your Linux machine, air-gapped and everything you need to do. But in our case, we can just use exif.tools, upload it to their website, and it will give us the metadata from this photo, which really, I love DoD. They tell us the names of the football players who are in the helicopter. So of really interest to us is the time and date that this was taken. Unfortunately, it doesn't have geolocation on it, but we can get that from ADSB Exchange, which had the best data at that time last May. We go to Historical Data Viewer, and we convert the time from that photo into UTC and plug it in here. And we see an aircraft that is very clearly flying around FedEx Field at that time. However, it is not using ADSB. It's using an older transponder code. There are several of these, Mode S and Mode C, that don't transmit the geolocation. So how are we getting it on the map? Well, that's by using a technology called MLAT. And MLAT is something that flight aggregators use to calculate the locations of older transponder codes using time of arrival at multiple feeder sites. So moral of the story here is that we find that this exemption is very broadly used. It's used for honorary funeral flyovers at Arlington Cemetery, ballpark and stadium flyovers that the military is paid to perform, air shows, photography missions, and recruiting events, just to name a few. So we were interested in how we could get data before the helicopters in flight, ideally. And the most obvious way to do this was using the President's Daily Schedule, which is published every morning for the press pool. And you can read through it and find events like this, where the president is departing the White House for Joint Base Andrews from the South Lawn. So there's only one way you could get to Joint Base Andrews from the South Lawn, and that's via Marine One. Of course, anybody in this room could scrape this website pretty trivially with Beautiful Soup or Selenium, but they let us download a CSV file, so we just did that. And the last part of this was, well, how am I going to schedule these to tweet at certain times of the day? And the answer was cron, the Unix system scheduler that's pre-installed on Linux systems. And you can interface with it via a Python library to add, edit, and delete cron jobs. So that's how we get automatic Marine One departures and arrivals. There's another data source, if you're from DC, you'd be familiar with it, called Alert DC, but many urban regions have this. It notifies you of traffic alerts, extreme weather events, but of critical importance to us are crime alerts where a police helicopter might be circling, and occasionally we get a notification about a flyover at one of those ballparks or Arlington Cemetery. So I'm going to show you a different way of approaching this problem, and that's using Make.com. Make.com is free up to 1,000 uses of these modules a month. So I really think you guys could find a use for this as a prototyping tool for Python. Before you set about writing your code, figure out how it's going to flow through the module, and ours flows like this. We look at this data source every 30 minutes. We download the website. We parse the website. In this case, that means converting the HTML into plain text. And then we compare the most recent date on that website with the last date that we stored in a Google Sheet. And the integration with Google Sheets is really awesome with Make.com, which helps for our uses. From there, we use a text parser again, in this case with a regular expression, to deal with the unique way that DC police describe addresses. You will see them say things like the 8,000 block of O Street Northwest. So this regular expression just finds an address in the alert. If that exists, it sends it to Google's reverse geocode API. This is an API where you send Google an address, and it sends you back latitude and longitude. So if we get that far, we then query our MongoDB database, which we have some historical access for. And if there is an ADSB craft over that, we send it to social. If it finds the word flyover anywhere in the alert, then it sends it to a private Telegram group, which I've given you all access to in the Slack if you are in DC and interested, so that our moderators can set up a scheduled alert for that or kind of figure out what the best approach is going to be to announce that. So the next part I want to tell you about is in October 2020, we started CopterSpotter, which is a process that allows DC residents to self-report helicopter activity over them with a couple pieces of data, a photo or video if they have it, the type of helicopter if they know it, and information from Twitter at the time was time, date, and geolocation. And with that information, we could map your helicopter spots and repost them to our account with information that ties that type of helicopter, with the GAO report we mentioned at the beginning, to a probable operator of that type of helicopter in the DC region. And this created a running feed of helicopters in the DC region. And to get people to actually do it, we made it a game, so people have had fun collecting CopterSpotter points. Of course, we also have a data viewer that is created by my colleague Sam Reese, who's here. Thank you, Sam. This is an awesome tool for browsing our data and looking at days past and specific operators if you want to filter it by that. And it runs on Mapbox, Node.js, TypeScript. If you're interested in any of that, Sam is in the Slack, Sam Reese. A little bit about our data that we've collected. In 2021, we collected over 10,000 of these spots, 8,000 or more in 2022, and more than 6,000 in 2023. Now, there are reasons why our data has declined somewhat because of platforms at use, but there's also an increase in security missions around elections. So I would expect that we're going to have a lot of action later this year. And looking at our data from last year, it could look kind of ho-hum with the operators that are available on ADSB. But in fact, we're collecting all of this information on military aircraft that the FAA does not collect because they do not track military aircraft. And so, people may have critiques about this, but there are reasons that it's very important to know where helicopters are and where they aren't. So I want to show you our data from January 6th. Leading up to January 6th, when there was normal military helicopter training happening, and then the day of January 6th, only DC police was circling the Capitol. And we have this data, and the FAA doesn't. So that's just to demonstrate the power of this data set. So we faced another problem now, and it's an existential one. Twitter is now owned by someone who's publicly at war with flight trackers. I don't think I have to tell any of you what a champion of free speech Elon Musk is, right? Okay, so he banned ElonJet, several journalists who wrote about ElonJet, suspended me for tweeting an ADSB link, not even to his jet, and so we later found out that he is not even doing the maximum amount possible to conceal his jet. He's not on the PIA list. He's only on the LADD list. So it's publicly available data. And then in a further kind of hit to our program specifically, they discontinued Foursquare API, and this is the API that let you tag the Westin Hotel or the park next door. But now if you try to tag your location on Twitter, you're likely to see something like Arlington, Virginia, or Crystal City, much larger swaths of land that weren't going to be useful to us. Of course, that didn't end up mattering because then they cut back their free API, and I'm sure you all know about that. We can't even read our own mentions list with the free account. And of course, I'll be damned if I'm going to give this guy a dime of my money. So we started looking at other options. And here we saw what bots, which socials are friendly to bots. And really the deciding factor was which socials were going to be friendly to geolocation. And so we moved to Telegram. And now you can talk to our Telegram bot, copterspot. This runs all on Make.com, by the way, which is pretty cool. And if you tag a location, doesn't have to be your location. It can be off in the distance where you see a helicopter. It will start a copter spot and add that data point to our data set. It will also query our MongoDB database and look for ADSB operators in the region and give you that operator info. So already we're getting more information to residents than your normal flight tracker, which doesn't tell you who the operator is in many cases. Of course, we then have a problem, which is that normal people really can't identify helicopters that well. We really tried. We tried to teach people how to identify helicopters, but after collecting a lot of great photos and videos, we decided it was best to just create a computer vision program that automatically identifies the helicopter for you. And so in this case, it did so with 87% accuracy, and it was correct that it is either DC police or DHS who operate the same type of helicopter. So there is some overlap, but we benefit from the types being pretty set to different operators in the DEC region. A little bit about this computer vision program. It is made up of 5,000 user-submitted images. We have many more, but annotating is a pain. So it detects 19 distinct types of helicopters, and in 1,000 cases where we tested it in 2022, or users just used it organically, actually, it was 77% effective in finding the correct operator. And if you want to try it, you can go to copterspotter.com right here and take a photo of our test helicopter. You may need a blue background, though, so I'm going to give you that. And so copterspotter.com, you can try our computer vision there, and you don't have to log in or anything or give us any private information. This is done with the aid of RoboFlow, which is a startup with DC roots that has been a really great partner for us. They have a free account that can walk you through all the steps of creating your computer vision program, and a lot of great tutorials too. The only catch is you have to open source your data set. So if you're willing to do that, they can offer you data set management of all your huge image data sets in the clouds, and annotation and labeling tools, as well as collaborating with other people. Like I said, annotating the images is the most laborious part, so bring your interns. Generating augmentations. This is where you automatically rotate an image a little, do adjustments to hue, saturation, and contrast to make up for different cameras. And this can multiply the number of images in your data set, which makes your model a lot more robust. They can train your model on their platform, which saves you from having to rent GPU time from Google or Microsoft, and offer you hosting for that model so that you can interact with it via an inference API, which just means you send it an image or you send it a link to an image on the internet, and it will do computer vision on it and send you back the result via a JSON string. And it also has an API for uploading new images to it. So if you need to do a lot of autonomous uploading, it can help. Because you're open sourcing your project, you can benefit from the RoboFlow universe of open sourced models as a starting point for any of your projects. So that's a really great tool as well. So the last part of our talk has to do with visual identification not really working at night. And the hint as to our last data set is right there in the picture, because even government and military helicopters have to talk to DCA's tower when they're in the region. And they talk to DCA on the approach traffic channel. So there are a lot of planes, and we'll talk about that in a second. But we started intercepting or receiving these radio calls, if you will, via a Raspberry Pi in a waterproof case with an RTL SDR and an antenna very close to DCA and where we are presently. And from there, it uploads each individual call to an FTP server, and you can query it from our Telegram bot by typing /radio, and you get a list like this. Telegram is really awesome for audio, by the way. And you can listen to calls like this, which you don't have to hear specifically. Reply to it with information about the call sign, waypoints, routes, and zones that are mentioned in that call. And then we build a map of the described waypoints, routes, zones, and very detailed operator information so you don't have to read the FAA route chart. And we have found that this has been very transformative to DC residents' understanding of flight paths as a whole. It also has brought to light some new shocking things, such as this, and you can turn it up a little more for this. So this is a Coast Guard helicopter declaring a near miss with another military helicopter, neither of which were using ADSB at the time. And we wouldn't know about this if we weren't capturing these radio calls. So I mentioned that they talk on the approach channel, and we were trying to limit down the 5 million approach traffic calls per month that are mostly planes to the some thousand or so helicopter calls a month. And we looked to OpenAI's Whisper automation. Actually, Matt Edmondson turned me on to this at this year's Recon Village, so thank you, Matt. And you know, I was pretty sure OpenAI's Whisper was not going to be able to tell us call signs or any really aviation-specific lingo, but it is surprisingly good at pulling out keywords that helicopters use, like routes and zones and altitudes and squawk codes, and importantly, information that planes use, like ground directions. They say Juliet, November, taxi, runway, cleared for takeoff or landing. And so using a regular expression like this, the simplest regular expression you'll ever see is yes to these and no to these. And we run this as a shell script in line with OpenAI's Whisper to say if a word is on the yes list and not on the no list, then we send this to a private Telegram group where it can be reviewed by moderators, and you have access to that group as well in the Slack. So in conclusion, thank you all for listening to this. I hope that maybe this talk inspires you to use your OSINT superpowers for the good of your community and help people understand a difficult topic. I think they started the timer a little late, so I don't know if I have time for questions. Maybe 4 minutes for questions?